Good morning, everyone. Today we're going to talk about limits. Limits are a calculus topic, and it is something that we're just going to introduce. We're not going to go super deep into it, but we're going to introduce it. So, limits. Let's talk about limits. So, this may seem kind of complicated. So this is, as you read this is the limit. Like, what is the limit as x approaches 5 of this equation, 3x minus 7. So here's a graph of this equation, and then here's the equation for this. And so as x approaches 5, we're looking at what happens to the graph, we're looking at what happens to the equation. So here is x equals 5. And as I approach from the left side, what is the graph doing? So as I approach from the left side, this looks like the limit as x approaches 5 from the left. And here, from the right side, x approaches 5 from the right side, or the positive side. And so that's the limit. So as I approach from the left and as I approach from the right, they need to be approaching the same value in order for the limit to exist. And so for this particular line, or this particular graph, as I approach from the left, lines are hard, as I approach from the left, the y values are increasing towards this value, and as I approach from the right, the y values are decreasing to this value, and this value is 8. So the y value as I approach from the left or from the right to this particular x value, I'm looking at what the y value is going to be. And so the y value here is 8. And so there's a couple ways you could find it. We just looked at the graph. So you could look at the graph and see what is happening as I approach from the left, as I approach from the right. Or you can just plug it into the equation. So I have 3 times 5 minus 7. So that would be 15 minus 7 is 8. And that's the limit. That's the y value as I approach and get infinitely close and close and close and close and close to that value. So that's kind of our initial example. So we're looking at the y value as we approach specific x values. Okay, here we have the graph. We have a table that we're going to create, and we have the limit as x approaches 0. Well, if I try to plug this in, 1 divided by 0 is undefined. You know that from early on in the year. Okay, and so it's undefined, so this is inconclusive. We can't tell what's going on. So if I call this 0, I need numbers that are going to be infinitely close to 0, but not ever touching 0 because 0 is undefined. And so some values like that, we could say 0.1. 0.1 is close. And we can get even closer, 0.01. And then we could get even closer, 0.001. And then on the other side, so this would be the limit as x approaches 0 from the right. This would be the limit as x approaches 0 from the left. So this would be negative 0.1. This would be negative 0.01 and negative 0.001. As I approach from the left, as I approach from the right. And so when you're in class, this might make more sense because you'll have a calculator. But if you have a calculator, you have the app, go to the calculator, and I'll show you how to do it here. So go to second window, and that'll open the table set, and you want to change the independent variable here to ask instead of auto. Okay, so you're changing your table, how your table gets set up. So put that in, and then you can go to y equals and put in your actual equation, which is 1 divided by x. Okay, so we went second table set, and then y equals. Then I want to go to the actual table. So second graph, which will open the table, and nothing appears because what you changed was you wanted the independent variable to ask you what you wanted to find. And so what we wanted to find are negative 0.1, enter, negative 0.01, enter, negative 0.001, enter. Okay, and so, I put an extra 0 on that one. But you get the idea. It's negative 10, negative 100. That one would have been negative 1,000, and now we're at negative 10,000. And then on the other side, we have 0.001, enter, 0.01, enter, and then 0.1, enter. And so what's happening here is as we approach from the right, these numbers are getting bigger and bigger and bigger in the positive direction. But as we approach from the left side, these numbers are getting negative 10, negative 100, which is even less, and then negative 1,000, and negative 10,000. So these numbers are getting really, really, really small in the negative direction. And so what's happening here, if we go back, we have negative 10, negative 100, negative 1,000. This one is undefined. This is positive 1,000. This is positive 100, and this is positive 10. So as we approach from the right, it's getting bigger, 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 which would be positive infinity. As we approach from the left, it's getting negative, 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 and that's negative infinity because it's getting bigger and bigger and bigger. So as we approach from the left and as we approach from the right are going different places, which means that the limit does not exist. Okay? And so because the limits are going different places, so here we have one's going up forever, one's going down forever, and so because they're going different places, the limit does not exist. And if you've ever seen Mean Girls, she says that at the end of the movie. The limit does not exist. So watch Mean Girls. You won't be sad. It's the best movie ever. And really funny. So they talk about limits in that movie. The limit does not exist. Okay. And then we could look at it graphically. This one's going up forever, this one's going down forever, just to be 100% clear. So you can look at plugging it in, you can look at the table, you can look at the graph. Okay. Then we have another equation. If I plug this in, this would be 5 minus 5, 5 plus 2, 5, oh that's bad, minus 1, 5 minus 1, and then 5 minus 5. So what ends up happening is this is 0, and this is 0, and it would end up being 0 over 0, which doesn't tell us anything. It's not helpful. So then I have x minus 5 and x minus 5, and you're like, oh yeah, those things write out, like when we were talking about rational functions a long time ago. So x minus 5 divides out with x minus 5. So now, if I plug that value in, I have 5 plus 2, 5 minus 1, which gives me 7 over 4. So the limit here should be 7 over 4. But let's check and see. So if I want to approach 5, this would be 4.9 and 5.1. And so we need values that are in between those. So 4.99, 4.999, 5.001, and 5.01. So when we go and plug this into the calculator, go back to the calculator, it'll look exactly the same before. So we need to put in new y values. So we have parentheses x plus 2 divided by x minus 1. Okay, and then we want to go to our table. So second graph, we'll open up the table, but I don't want these values anymore. I want 4.9 there, 4.99, oops, 4.99, enter, and 4.999. 5.001, 5.01, and 5.1. Okay, and so what we see is all of these numbers are approaching the same value, 1.75. So these are all approaching 1.75, and then now these are all bigger than 1.75. And so if we look at the graph, we can see the same thing. Okay, so this is well, we can see that on the calculator. Same thing here is happening here. So this is getting closer and closer and closer, because this is the x value that we're looking at. This one is getting closer and closer and closer and closer and closer. There, the two values for y are approaching the same number. So they're getting closer and closer and closer to the same value. Before we were going down forever and the other one was going up forever. Now we're going, they're headed towards the same value. So this is the value that we're looking for. Even though there's no point there, there's a hole there, it doesn't matter. It's what is happening as you get infinitely close to that value. So originally, there's a hole because it's undefined, but just because there's a hole in the graph doesn't matter. Also, if there's a hole in the graph and then someone came in and plotted a point here, the limit here would still equal, as x approaches 5, would still be equal to 7/4, because this, just because there's a point there doesn't mean that the limit as we approach that value is approaching this. It's not. It's approaching this value at 7/4 or at 1.75 like we saw in the calculator. So that is kind of a quick overview of limits. Here are kind of the main ideas of what you can look at. Plug it in. Can you eliminate anything? Can you divide anything out? And then use a table or a graph to look at what's going on. Okay, so that's kind of limits, and I'll make another video when we're talking about infinite limits, so what's happening at infinity. So go ahead and watch the next video if you're ready to talk about infinite limits.